Hello everyone, welcome to my YouTube channel. So in this video we will proceed further with various soil name as listed here. So we will discuss these soils one by one. So let's start with the most important soil type in geotechnical engineering, which is bentonite. So bentonite is an expensive, highly plastic clay composed primarily of montmorillonite formed from weathered volcanic ash. In geotechnical engineering, it is prized for its extremely low hydraulic conductivity and ability to swell up to 18 times its dry volume, making it essential for sealing, containment, and structural excavations. The key engineering properties of bentonite includes high swelling and shrinkage, low permeability, high plasticity, and its thixotropic gel formation. So in thixotropic gel formation, when it is mixed with water, it forms a stable viscous gel that is excellent for suspending drill cuttings and stabilizing trench walls. Next we have the primary applications of bentonite. So the primary applications of bentonite includes landfill liners and covers. The compacted soil bentonite mixture are used to create impermeable barriers that protect groundwater from hazardous leachate. Next, its application includes slurry walls. Soil bentonite or cement bentonite slurries are used for defoundation, cutoffs, dam or levees, seepage control, and environmental containments. Next application is drilling and piling. So bentonite slurry served as a stabilizing fluid during deep excavations like diaphragm wall and board piling to prevent trench collapse. The geotechnical challenges and its mitigation are settlement and failure, as it is highly compressible, so the risk of settlement and failure are there if the foundation construction is directly done over it. So the unmodified bentonite causes large settlement and it has low shear strength, making it generally unsuitable as natural load bearing subgrade. Next challenge includes desiccation cracking. As the soil dries, as it can absorb high amount of water, so if it dries, it shrinks and it can crack, which can compromise the structural integrity of a barrier. The next geotechnical challenge includes its stabilization. So engineers often stabilize bentonite and problematic native soil by blending them with additives such as lime, cement, recycled waste that are fly ash, glass powder, etc. to reduce its plasticity and improve unconfined compressive strength. Next we have black cotton soil. So black cotton soil, short form BCS, is one of the most problematic expansive clay soil in geotechnical engineering due to its severe volume changes. It is derived from basalt lava rocks. It is rich in montmorillonite clay mineral, which expand significantly when absorbing water and shrink drastically as they dry. This seasonal movement generates high swelling pressures, causing extensive damage to the foundation, pavements, and retaining walls. The core engineering properties of black cotton soil are: it is classified as highly compressible clay (CH). We will understand the various classification of soil in geotechnical engineering in our next lectures. So, it is classified as highly compressible clays (CH) under the Indian Standard Classification System. The next core engineering property is high plasticity. So, the liquid limit of black cotton soil generally ranges from 50% to 100% with high plasticity index. We will study the various indices like plasticity index is equals to WL minus WP. So, if WL is very high, so we have high value of plasticity index, so which is written here. The next engineering property of black cotton soil is low bearing capacity. So, it exhibits poor shear strength when wet with a soaked California bearing ratio often below 2%, which is of very low strength soil. We will study this term in our next lectures. Next we have low permeability. So, its extremely fine grained matrix restrict the water movement, causing prolonged moisture retention. Next we have the engineering property of black cotton soil as volumetric instability. The low shrinkage limit leads to massive deep cracks up to 15 to 20 centimeter wide and several meters deep during dry periods. So, the geotechnical challenges of black cotton soil includes differential settlement. So, the uneven swelling and shrinkage beneath the footing cause distort building frames and crack walls. Next challenge is pavement failure. The subgrade moment causes rutting, potholes and extensive cracking on flexible road surfaces. Next one we have high swelling pressure. The uplift forces often exceed the downward dead load of light structures, lifting foundations out of place. The ground improvement and stabilization techniques of black cotton soil includes chemical stabilization, industrial waste utilization, mechanical stabilization and fiber reinforcement. So, in chemical stabilization, different types of chemicals such as limes triggers a cation exchange that reduces plasticity, while the cement forms cementitious bond to improve its immediate strength. Industrial waste utilization includes the mixing materials like fly ash, ground granulated blast furnace slag, that is short form is GGBS, and FGD gypsum modifies the soil structure. Mechanical stabilization includes the adding of granular admixtures like quarry dust, stone dust, increases internal friction and reduces overall expansion. The fiber reinforcement includes mixing of discrete fibers, that the example includes polypropylene, sisal or PET, enhances tensile strength and checks crack propagation. Next we have foundation design solutions for the constructions over the soil which is of a type black cotton soil. So, foundation design solution includes the uses of under-reamed piles. These are board cast in situ concrete piles, features enlarged bulbs anchored deep into the stable non-expansive soil layer to resist uplift forces. Next one, we have soil replacement. We generally replace the soil, black cotton soil, with some high strength soil, excavating the top layer of expansive clays and replacing it with compacted cushion of non-cohesive sand or gravel. Deep foundation includes extending footing to a minimum depth of 1.5 to 3.5 meters, where the seasonal moisture variations are negligible. Next one, we have moisture barriers and drainage. Installing rigid plinth beams, waterproof aprons and efficient surface drainage channel keeps water away from the foundation perimeter. As we have studied that in both of these type of soil, bentonite and black cotton soil, we have the clay mineral same, that is the montmorillonite. So what is the difference between these type of soil is a very common question in various type of interviews, and very common question that comes in the mind of students. So bentonite and black cotton soil are both heavily studied expansive clays in geotechnical engineering. While they share the same problematic clay mineral, this is montmorillonite, they are completely distinct material in the terms of their purity, origin and scale of volumetric change and practical engineering applications. The primary difference is that bentonite is a highly concentrated, commercially processed clay mineral formed from volcanic ash, whereas black cotton soil is a natural residual soil layer formed by weathering of basaltic rock containing a mix of clay minerals, silt, sand and organic matter. The key engineering differences of these two type of soil includes these as listed here. These differences are categorized based on these features: origin, or we can say formation, the mineral purity, liquid limit, swelling and shrinkage, permeability, field occurrence and their engineering role. So the bentonite soil formed from, as we have already discussed, formed from chemical weathering of volcanic ash decomposition. On the other hand, the black cotton soil are formed with the in situ weathering of basaltic lava rocks. In the terms of mineral purity, the bentonite soil contain extremely high percentage of montmorillonite mineral with up to 60 to 90%. On the other hand, the black cotton soil contain moderate quantity of montmorillonite mineral, typically of 30 to 50%, and it mixes with quartz and iron oxide. In the terms of liquid limit, the liquid limit of bentonite soil exceptionally high, which is up to 500%. Generally it is ranges from 200 to over 500%. On the other hand, the black cotton soil has liquid limit up to 100%. So here we have seen the liquid limit of bentonite soil is higher than that of black cotton soil. Swelling and shrinkage. So extreme volume changes can swell up to 10 to 15 times of its dry volume in the case of bentonite soil, but in the case of black cotton soil, it swells up to 2 to 3 times its dry volume. Permeability, we have virtually impermeable bentonite soil layers are there. The K value ranges from 10 to the power minus 11 to minus 12 meter per second, and on the other hand we have black cotton soil permeability ranges this one. Next one is field occurrence. So it is found in localized concentrated sedimentary geological deposits, but the black cotton soil covers vast surface regions that are Deccan Plate in India, parts of Africa, etc. Their engineering role includes it is used as bentonite soil used as engineering tool material like slurries, liner and sealant, but the black cotton soil is encountered as a problematic foundation subgrade. So these are the key differences. Next, their conceptual breakdown we should study. So in the terms of mineralogical concentration, the bentonite soil, think of bentonite as a pure montmorillonite clay because of its immense concentration of smectite mineral. Its surface area is massive, causing unparalleled water absorption and electrical double layer repulsion. But the black cotton soil, it is a top soil matrix while it behaves like montmorillonite due to its clay fraction. It is heavily diluted by inert silt particles, sand grains and organic matter. Consequently, its expansive behavior is lower than pure bentonite. Second one is hydraulic conductivity, which is also known as permeability. So bentonite, when hydrated, swell to form tight jelly-like impervious mass. This low hydraulic conductivity makes it excellent for fluid blocking applications. On the other hand, black cotton soil, it holds water tightly and drains poorly, so its structure is still porous enough compared to bentonite to allow low seepage, which is why it undergoes dramatic deep seasonal wetting and drying cycles in nature. So if we talk about practical applications in geotechnical engineering, bentonite as a solution, engineers actively buy and transport bentonite to use as drilling mud, stabilize borehole walls. It is also used in geosynthetic clay liners, GCLs, for landfill containments, and it is also used as sealing slurry to prevent groundwater contamination. But if we talk about black cotton soil, it is a hazard. So nobody buys black cotton soil for construction. Instead, civil engineers develop specific methods to escape, replace or modify it because of its actively destroyed roads, light buildings and pipeline built directly upon it. So that's it for today. Today we have discussed the lists of various soil names that are commonly used in geotechnical engineering. We have discussed bentonite, we have discussed black cotton soil, and we also discussed the comparison between these black cotton soil and bentonite soil. So I hope you understood the concept of these two types of soil. In the next video, we will proceed further with another soil type. So thank you very much.